Well, good morning. This is certainly the first time I have been on stage in a church talking to people. This is sort of weird, but we'll see how it goes. My name is Ben Leduc-Mills. I'm going to talk about education stuff. Uh, I work at SparkFun. You can call me Ben. I work as a R&D Swiss Army knife. That's actually my job title. That's what's on my business cards. I don't know what it means any more than you do, but I do a lot of stuff. I got a PhD in computer science from the Craft Technology Lab in CU Boulder. For those of you that know Lilypad or Leah, that's where she did her dissertation, so lots of cool stuff hanging around there. Before that, I was at IBM Art and Technology Center. Some of the very first open hardware discussions happened at IBM. I was a lowly web developer there at the time, but I saw some cool things happen. And yes, I'm also an ITP alum. There are a few of us here. Go ITP. All right, so what I kind of want to talk about today is the intersection of open hardware and education. And this is a huge topic. So the caveat immediately is I'm only going to scrape the surface. But I do want to point out something that actually Anne-Marie also touched on, which is that open hardware is sort of inherently learning focused, right? The fact that we open up our schematics, our documentation, sharing knowledge is essentially like the foundational building block of education, right? Without the sharing of information, you don't learn anything. However, there's a sort of interesting dichotomy between the values that a lot of open hardware hackers have and the values that are often present in education. So we love words like bootstrap and self-efficacy and being a hacker, hacking in your garage late at night and figuring out everything by yourself. And that's great. I love that. I do that. Cool. However, that's not really how a lot of mainstream education works. So what's been really interesting is that all of these sort of makery ideals have started to percolate into education in a really big way all of a sudden. So how do we translate these maker philosophies into sort of bridging the gap between open hardware and traditional education, right? The fact that we have been sharing things is actually one of the reasons that education has been sort of eager to adopt, right? We have all these tutorials, we share our code, we share all these things. Makes it a lot easier for teachers to get their hands on Arduino, things like that. But what are the new tools and the languages and practices that we need to bridge this gap? So as hackers, as builders, engineers, we've always valued sort of the experience, the learning experience of being hands-on. So the act of construction itself as a powerful learning tool. And a few academics out there have long realized this. So if any of you have read Seymour Papert, he wrote this book, Mindstorms. It came out in 1980. We're just now catching up to him. So if you haven't read Mindstorms, go read it. It's actually pretty good stuff. And so now we're starting to see these words in education conferences like project-based learning, inquiry-based learning, embodied cognition. So these ideas are sort of actually percolating down. Now, this is arguably good for open source hardware in general. Educators buy things too, so economics. And places like the NSF and the Department of Education are actually starting to make calls for things that are maker focused, right? That can rely on open hardware for actually getting funding. So yeah, that's cool. Let's do some research. And finally, academia is becoming home to an increasing number of open hardware friendly labs, professors, people. Many of you in the audience are part of that. So what does the model for industry academic partnerships look like? So I'm going to give a few examples. There's not one right model. There's not one wrong model. So Leah, we like Leah. Is Leah here? I don't think so. Anyway, so while she was a doctoral student, she started developing the Arduino LilyPad with SparkFun, and eventually that became a product, and SparkFun manufactured it, and she went off to MIT and kept doing her thing. So that's a model, like develop a thing, hand it off, you have a product, right? That's good. Josh Pierce, I think, is in the audience. He's giving a talk later. Hi, Josh. We haven't met, but we've emailed. So Josh has a really cool lab in which he basically gets to make open source hardware lab equipment. So the university is basically sponsoring the sustained research focus in making open source tools. And that's really cool. That's like a huge win for open hardware. I know Tom is in the audience. Tom gets to like be embedded in this creative vortex of ITP students and just see how they're using all of this new technology in creative ways, and then bring some of that knowledge back to his writing and to Arduino, and makes him the brilliant human that he is. Checks in the mail. And there are a variety of people that do this stuff, right? You're all here, you all know what you do. I'm not gonna bore you with that, but talk to your neighbors during the break. Somebody here is doing something pretty interesting, probably with an educational bent. At SparkFun, we've sort of adopted two strategies. So we have a service model, right? So we do workshops. You can pay us to come out and teach you. People do. We have contracts. So Intel has worked with us for a while, the Galileo and the Edison. We do tours for them and teach their people. We also do custom kits. So UIUC, any UIUC alum in the house? So we do a kit for them, their beginning undergraduate class. We've done stuff for MESA, which is like a math, engineering, science achievement that covers most of the western half of the United States. So that's also pretty cool. The second part is a research model. So we've sort of only started doing this in the past year or two in a formal way where like we apply for NSF grants, but we've always been doing this, right? SparkFun was built on tutorials and making stuff accessible. So we write books. Our guide to processing just came out. If we have processing fans in the house, you should check it out. And we distribute all of this stuff for free, right? We generate all these materials, we distribute them for free, and we sort of think of it as open education. So if we're at the Open Hardware Summit, there could be conceivably an open education track or something like that. This is sort of inherently part of open hardware, but directed towards teachers who don't necessarily want to think about all of the little nuts and bolts and just want to get things working. So yeah, we also write papers, we go to conferences, we apply for grants, we do all this stuff. So why do we do this? And what are the sort of takeaways from our specific approach? So the education market is using and producing more open hardware. It makes sense to sort of pay attention to that and see how we can help them. What's great about the research part is that we can work with them to start to answer some key questions about learning and making stuff, right? So as open hardware practitioners, you're hacking in your garage, you don't need to be concerned whether or not you're learning anything. But it would be great to know if actually your engineering students or whoever your kids might be learning with or from, does making actually make a difference? And what kind of tools and what kind of pedagogy do you need to actually be effective there? And finally, one of the things we really try to care about in our department at SparkFun is supporting research that has a social justice element, right? So whether it's getting more girls, getting a broader diversity of people into engineering, making sure there's accessible means to all of this technology. That's something that we care a lot about, and we've been fortunate enough to find some people that will help us out with that. And so things are in the works. I can't say much more at the moment, but we're trying to make good things happen. However, there's certainly some obstacles to overcome. So universities love patents, they love IP, they love tech transfer, right? So one of the main questions here is how do we get universities to allow open hardware to exist, to flourish, without them getting all of the IP and shutting it down? I don't have a particular answer to this, but it seems that more and more universities are open to sort of letting the IP, in some cases at least, be open. One of the main things is K-12 schools are resistant to change. They want stability in their platforms, right? They don't want to buy a new kit every year. They want the same kit to work for 10 years. And open source hardware, we like rapid iteration. We like tossing out an idea, seeing if it'll work, and then moving on to something else. So it's sort of an inherent disconnect there. We need to sort of think about what platforms, what stability we can offer to them. This is one of the reasons that we did the red board at SparkFun, so that we could keep the design the same. Educators love that. It's great. However, it's easy to conflate the tools with the results. So what I mean by this is there's a shortcut to like, oh, if we give all the teachers an Arduino, like that'll be great and the kids will learn things. And that's not true, because you actually have to have pedagogy and you have to have some design behind that. Otherwise, you just end up in a bin somewhere and nothing good happens. I also have a bunch of big questions that are sort of unanswerable about like 21st century literacies, right? So do all the kids really need to code? Do all the kids need to like be engineers, right? So this is sort of, this community, we like engineering, we like building stuff, but it's not for everybody and doesn't have to be for everybody. So let's try to keep that open mind. And I don't have all the answers. But I do think, for some takeaways, we are in a position to influence a generation of learners while there's all this energy behind the maker movement. So there's a lot of attention being paid right now. Like our friend in Texas who gets invited to the White House, right? For this wouldn't have happened not too long ago, right? He actually gets all this opportunity now that comes out of a bad thing, but there's a lot of attention being paid to this sort of movement, and let's capitalize on it in a way that matters. There's not a right way to do this, but there might be some wrong ways. Let's be inclusive. Let's not force everybody to be an engineer or be in STEM fields. And there's a lot of open questions around this, but let's be critical and conscientious of the impact that we have as innovators and educators. Even if you don't work directly in education, you never know what student is going to be Googling their homework and come across your documentation online. And that's pretty much it. Thank you. Just a few things. Sorry for all the bad musical puns in the titles of my slides. I really wanted to use Fly Like an Eagle CAD, but I couldn't fit it in anywhere. Anyway, thank you.